Hey everyone, this is Mayur. Welcome back to MLOps. In this video, we'll be discussing how to set up Ray on a Kubernetes cluster. So before we get started with Ray on Kubernetes, I would like to suggest that you go ahead and watch the previous video on how to set up Minikube in locally. Okay, once you are done with that, then only you can follow this tutorial. Otherwise, it's quite pointless to watch this video. But just for the sake of information, you can watch what is happening here. So first thing is, I have already up and running Minikube. So Minikube cluster is where I'll be hosting my Ray framework. So what is Ray? First of all, Ray is nothing but an open source framework for distributed computing or parallel computing. So this is predominantly used for machine learning application, for like scaling the number of inference services or training a job on a multiple GPUs. So all those can be done by Ray. So when it comes to what installation aspect, you can install Ray as a standalone, or you can install Ray on a Kubernetes environment using KubeRay. Now, why do we need to use KubeRay in the first place when you have standalone setup Ray? So consider you have like hundreds of machines, okay, but you want to interact all the nodes you have to interact, all the workers you want to interact with. So that is the basic definition, right? The way how Kubernetes works. It helps you to scale the applications on multiple pods whenever there is a demand and request. All those can be done using Kubernetes, and to enable that for Ray, KubeRay comes into picture. Now KubeRay is a way to create Ray clusters inside Kubernetes, and Ray cluster goes ahead and creates head node and worker node. So whenever you are trying to set up Ray cluster, head node and worker nodes are something default that happens while you are installing Ray cluster. So with that, what I'll do is I'll go to the documentation, okay, or before that itself, right, what we can do is we can go through certain definition itself here. So Ray is nothing but an open source framework designed for building and running distributed apps. And you need KubeRay to set up Ray on Kubernetes environment. And for doing that, you need KubeRay operator. KubeRay operator will create a Ray cluster. So when it is trying to create a Ray cluster, it will create something called as head node and worker node. Head node acts like a master, and worker node is where the actual action takes place, where the actual program is running, or a model training is happening, or inference service is running. So these are some basic definitions. Okay, at the top you have KubeRay, and then you have KubeRay operator, and then you have Ray cluster, and then you have head node and worker node. Now we'll be seeing all these practically. Okay, before that, okay, so certain prerequisites that you have to have it in your system, local machine, okay, where you are running your Minikube. First is that you should have a Docker, and then you have Minikube up and running. So currently it is up and running for me here. So just to check, right, kubectl get pods. So there are no namespace, but the kubectl is able to understand that it is inside a cluster. Okay, so under the current namespace it is not having anything. So let me just do namespace. Okay, all the different namespace inside my Kubernetes cluster, which is Minikube. All these different systems are running. So now the first step is the prerequisite Docker thing, Minikube, and Ray default for running a Ray job locally, which is a Python package. And then you have Helm for installing Kubernetes modules, CRDs. Okay, for that you will need Helm. Now there are multiple ways. First step will be to create a KubeRay. So I guess if I go here, kubectl get, let me go to this documentation first. So what is the way to deploy KubeRay operator? You can either install using KubeRay operator using Helm, or there is other documentation. If you go here, KubeRay docs, that is one way is to through Helm chart, okay, which is this command, add this and then use KubeRay operator, install KubeRay operator. You can do this, otherwise you can do this one. So I have already installed KubeRay. Okay, I don't want to spend time here because it takes little time for installing KubeRay. So what will happen is, if you see here, this is the command kubectl create -k github.com Ray project KubeRay Ray operator. So this was the command. If you give this will be the output. It will give some warnings, and then it will create a namespace called as Ray system. and then there are certain CRDs that will be getting created, like Ray jobs, Ray clusters, Ray services, and there is a service account which is getting created, role, cluster role, role binding, cluster role binding, service, and then you have deployment. So all these things will get installed or created once you just hit this command, create -k github.com ray project KubeRay. So this will create your KubeRay in this specific cluster. So just to check, okay, let me go back here. I'll just do kubectl get pods. Let me see if it is giving us the pod. I'm not sure if it will run locally. Okay, it is under specific namespace. Get pod under Ray system, because everything got installed inside Ray system. So let me hit that. So here if you see, KubeRay operator is up and running. It has been running for almost 6 days now, and it got restarted 36 minutes ago. Now next step is the next step is generally you have to install something called as Ray cluster and then worker and head node. But to do that, you should have something called as Helm in the first place. For that, you have all this series of steps, and if anyone requires it, you can just send it in a comment, right? You can share your comment, and I'll just share this detail where it is stored. So this is the way to install Helm, and then you can add the Ray cluster. So what I'll do is, I have already added the repo. Okay, so what I'll do is just I'll go ahead and install Helm now. Not install Helm, I'll install Ray cluster using Helm. Just copy this command. Helm install KubeRay cluster, KubeRay Ray cluster version 1.2.2. So this will create Ray cluster. So it has deployed Ray cluster. Now what we'll do is kubectl get pods. Now if you see in the last 9 seconds, it has created a pod which is a head node, and there is a worker node which is part of your Ray cluster. Now if you want to see the Ray cluster, kubectl get Ray cluster. So this is our Ray cluster, and it is having one worker. It is containing 2 CPUs and 3 GB memory. It was started 27 seconds ago. So let me clear this. So we are at a step where we were able to, let me go to this documentation. So this is related to Helm installation. Then we started off with setting up Ray cluster by adding this one. Then we are installing the Ray cluster. We were able to see the pods. We were able to see the Ray cluster. Now we also saw head and worker node. So let me check, right? It was under container stage. Now let's see if it is up and running. Yeah. So both are up and running now, worker and head node. Now what we'll do is we'll try to run a Ray job on a head node or a worker node, and then we'll try to understand the dashboard where everything gets captured. So let me clear this. Then put it here. Go to the command again. So first let's execute a Ray job in head pod. Okay, so first what we'll do is get the details of head pod using this command. So let's understand this command, right? kubectl get pods. It will be selecting under the head node type. Okay, it will select the name of that specific head node type. So once this is done, let's do echo $ and then head pod. So this is the name of the head pod name. Okay. And now what we'll do is we'll try to execute a Python script inside this specific head node or pod. So let me just copy this command, which is the exec-it. It will try to do what you call it as docker exec, right? It is similar to that. Okay, it will go inside this head pod, which I have shared the information here, how the head pod name is taken from here. And then we are submitting a Python script here, python-c import Ray init and Ray cluster resources. So it will give you that cluster resources information. So the cluster resource information is 2 CPU and 3 GB memory, and then this is the node IP and object store, which is nothing but your hard disk, internal head 1.0, and this is worker node, I guess, worker node 1, and internal head is also 1. So let me clear this. Now we have submitted a ray job on the head pod. Now what we'll do is we'll try to use something called as ray package from Python. For that you have to install something called as ray default. Okay, so if I go, if you want for installing it, it is quite simple. You just have to do pip install ray, this one. Let me see if it's already present or not. So yeah, it's already up and there running. Okay, you don't have to do anything because even this takes time. So ray default is there, so we just have to submit a job now. Okay, first let me get this service details of the head. Okay, so this is the service detail of the head pod. So this is the cluster IP, this is the cluster IP, okay, and this has been running for last 4 minutes. Now what I'll do is, since I have this running inside this Minikube cluster, I want to expose it to my host machine. So for that I have to do something called as port forwarding. So this service was running on port 8265. So I'm trying to expose that to my local machine by using port forward. Okay, so it is already port forwarded now. Now what we'll do is we'll try to submit a ray job to that address where this is running. So let me open another shell. Okay, here let me switch to, since I have installed it inside a ray MLOps virtual environment, I'll switch to that. Source ml bin activate, and I'll try to run this job there. Okay, what I'm doing is ray job submit to this specific address. Okay, this is where I am, what service is port forwarded. Now I'm submitting a job again, ray job. So what happens? Let's wait. So while this is happening, since this is happening, let me go to the dashboard. Okay, if you see here, so once this is done, right, what we tend to do is we can access the dashboard to see the jobs that are running. Let me just copy paste this one on my browser here. So yep, so I have everything running. Let's see in the terminal. Yeah, so I had submitted a ray job here and it started with the jobs, what are the next steps, submitted successfully, and then it gave me the information that was part of your Python program. Okay, and then it gave the information that it is succeeded. The job name was ray submit mxuqs. So this was the job. If you are able to see this dashboard, okay, you can see the job recently that got executed, and if I go inside this, you will see the logs and everything. So this was the information, everything, and then we can go to the stack trace if required, and CPU flame. Okay, so it doesn't give much information, which makes sense. Okay, runtime environment. Okay, there is nothing to look at here. So anyway, let me see, right, what is the task table. All these are different informations. Okay, when you're trying to submit a job, right, like an ML job, you will be able to see all these things coming up here, getting captured. What is the job ID, process ID, what is the state of the job. All those information will be available here. So we are able to see all the jobs. So this was running from head pod, which we done like earlier. This was the first job. This is the second job which we submitted using Python package. Now, as part of the tutorial, what we have next is we don't have anything. We just have to clean up the things that we have installed. That I'll take care later, which is not required right now. So as part of this tutorial, what we understood is we were able to install KubeRay, and then we were able to install ray cluster, and then we were able to submit jobs on the ray cluster, and we were able to use the dashboard to view all our jobs. Okay, so in the next video, right, what I am planning is to how to interact with the GPU of a host through Ray, which is running on a Kubernetes. So we'll do that in the next video. So with that, I'll conclude this video and thank you so much for watching.